Good morning everyone. Welcome to 12th standard. Okay, so we're going to get started today with the first chapter of 12th standard syllabus, and that is a chapter about electric charge and electric field, chapter number 1. Okay, so at the very beginning of this class, I'd like to tell you that just like in 11th standard, here also the first book is in continuation, right? The first book is in continuation. Chapter 1 leads to chapter 2, 2 to 3, 3 to 4, 4 to 5, 6, 7, 8. Okay, so nobody can afford absenteeism. Nobody can afford laziness, especially in the first book, right? Okay, there are two parts here. Once again, just like in 11, the first part is bigger, right? Both in size and slightly trickier in concepts as well. The second part, on the other hand, is quite simple, okay? And the second part is dependent on the entire first part. First chapter to last chapter. Alright? Okay? So please be careful about all these things. Another thing that I want to mention at the outset is that time to time we will have to refer back to 11th standard topics. Right, so whenever required, I will tell you that you have to refer so and so chapter, so and so topic from the 11th standard syllabus, and you must do it. I will avoid repeating anything that I have taught in 11th standard. I am making it very clear. I will avoid repeating anything that has been taught in 11th standard. Alright? Okay? And yes, please everyone, try to be more interactive. We are going to keep a record of who interacts with us in the class. I'm being very serious. Okay, we are going to keep a record of whosoever interacts with us. You see, the chat is recorded always by default. Okay, and we are going to contact your parents in case you are found to be just sitting idle. I'm being very clear. If you are found not to be giving answers, if you are found not to be trying, we are going to contact your parents and we might have to call them in here as well, right? So this will be the way we are going to go through with 12th standard as long as it's online, right? Or no, soon it's going to be offline, but then once again it's going to be online as well if cases rise again or anything, right? So online classes, they are just like classes, remember. Okay, just that you and me are at different places, that's it, right? But whatever interaction should occur between us as teacher and student must be there. There should be no change. So I will mention time to time what you have to revise. Okay, I mentioned it last time as well that you have to revise the chapter gravitation, didn't I? Okay, I hope everyone has come today having revised gravitation, because chapter 1 depends or is very, very similar to gravitation. Okay? Alright, fine. So let's get started with the content of the first chapter. Okay? The content of the first chapter. So now this chapter number 1 is about electric charge and something that is related with electric charge, that is electric field, right? So charge, electric charge and electric field, right? Electric charge and electric field. Now first of all we are going to understand how do people know about charges and all that. Okay, let's begin with that. I am sure you would have realized that often when two objects rub against each other or they move against each other, have you noted sometimes that in some seasons, especially in winter, when you sit on a sofa set or something and then when you stand up, you feel that your hair is standing up. Have you noted that? You also feel a shock if someone touches you. Have you noted such things? Yes or no? Again, interaction is important. Alright? So, why do these things happen? Right? They are essentially because of charge. Right? And things get charged when they rub with each other. Right? So this was mankind's first experience with charge. There are many other phenomena that are dependent on charge and its properties and everything, right? For example, lightning strike is just charge flowing from one point to the other point, right? Okay, but it creates terror, it creates, a great deal of damage, right? On the other hand, some other things related to charge are so simple, right? For example, I can write on this board, this is the magic of charges, to be very frank. What happens is that the charges in the ink, they get attracted to the charges on the board and they stick to each other. So until you apply some other force and remove it again by, the charges on this one, right, on these little threads, okay, of the duster, they are going to pull all those molecules out by using more force, okay. So that is how these kind of simple processes occur. Okay. Now, so charging by rubbing was mankind's first experience with charges, to be very frank. It's very old, probably somewhere around 1700 people started realizing that there's something like a charge. Okay, right? So let me tell you what happens when two objects are rubbed with each other, right? Typical examples are, let's say that there is a plastic rod. Okay, let's say that there is a plastic rod and you take some piece of cloth, right? Typically it will get charged with any piece of cloth. Okay, it's not like it will get charged with only one particular piece of cloth, but this is just an example. Do you need to remember the example? You can try it if you want. Okay, don't worry too much about it. Right? So suppose we take fur. I'm sure you know what fur is, right? Animals have fur. So this is a kind of historical example. So when we take a fur piece and rub it on plastic rod, what happens is that electrons jump from one to the other, right? So depending on where they go from. So some electron, actually in this case they go from fur to the plastic rod. I repeat what I said. Electrons go from, when you rub these two together, right? Let's say this is the plastic rod and you take the fur cloth and rub it like this. Okay, then the electrons are going to go from fur to plastic rod. So do you realize that when this fur will lose electrons, when the fur will lose electrons, it will gain positive charge? Yes or no? Yes or no? When the fur will lose electrons, it will gain positive charge. Okay, but on the other hand, this one gains electrons. Okay, this one gains electrons, and so it will get a negative charge. So it will gain a negative charge. Alright, so that is when these extra electrons come to it, it will become negative. Right? Okay, so not only this, right? Not only this is just like one example. There are thousands of examples possible, right? You can think of polyester clothes with your skin, right? Even in that case, your skin gets charged and the cloth also gets charged, right? So there are so many examples like this, right? We don't need to cover all of them, right? Okay. So basically, the gaining of charge. Why does it get charged? It's actually because of electrons. Right? Why does something get charged? It's because of electrons. When electrons are lost, something becomes positively charged. When electrons are gained, something becomes negatively charged. Alright, so this is some very basic information. Clear? Okay. Now video is clear? No. No, it's not. I mean, I'm standing in front of camera, but you can't see me. Okay, just wait a minute, right? I'll try to do something about it. Okay. Yeah, now video is clear, right? So there was a question. Let me answer that question before we proceed. It was from Rahul. He said, how will it lose electrons without any chemical reaction? Well, Rahul, I hope you realize physics is the king of sciences, right? All chemical reactions follow laws of physics, right? Okay, what really happens is some particular kind of molecules, they have more attraction for other molecules or other atoms electrons, right? So that's typically the case, right? So when you rub two objects against each other, you are giving them a little bit of energy, okay? And with that energy, it is possible that the first electrons go out, okay? They escape from the atom, and then the plastic rod captures them. Did you understand? Okay, so although there is no chemical reaction, I mean the way you understand it in chemistry, but actually there is something similar to a chemical reaction. Sahil, I hope you got the answer. It depends on the molecule's properties, right? If whatever molecule is there, if it can attract electrons easily, it will gain negative charge. The other one will get positive charge. Alright? Okay. Fine. So that's how we go through with charging by rubbing. Now, so remember, whenever any two objects are rubbed, unless when they are different objects, right? Let's say one is plastic, the other is anything like a cloth, or one is wood and the other one is like a cloth, or anything, right? Objects do get charged. Now, this was the first experience for mankind about charge. But what is charge really? It's a very difficult question, to be very frank. What is charge? Let's define them. We say objects get charged, but what is charge? Charge is a fundamental property. Charge is a fundamental property of matter. This is not its definition. Charge has no definition, to be very frank. Charge has no definition. Just like mass. Mass is a fundamental property of matter, isn't it? Right? Matter can have mass, vacuum cannot have mass. Similarly, matter may have charge, but vacuum cannot have charge. Did you understand? Did you understand this or not? Matter may have charge, vacuum cannot have charge, because charge is a property of matter. Alright? Only objects, bodies, particles may have charge. Right? Only objects, bodies or particles may have charge. Right? So, you might be thinking, what kind of property is this? But it is so basic that even after doing hundreds of experiments, we have not been able to understand anything deeper than charge. For example, if I tell you what is momentum, we can understand, okay, momentum is a vector and p vector is mass multiplied with the velocity of the particle or object. Very good. So we can understand momentum in form of velocity. Then we can understand velocity in form of position and all that, right? But charge is something which is so fundamental, so basic, that we don't know why objects have charge, right? Why particles have charge. For example, if someone is going to ask you, why does electron have a charge? Then all you can say is, no sir, I don't know, right? Okay, because nobody knows. The truth is, nobody knows. No, right? You can't say charge depends on mass. Charge and mass are completely independent properties. Charge and mass are completely independent properties. Okay, they have absolutely no relation with each other. Absolutely no relation with each other. But yes, one thing is true. Matter has mass and matter may also have charge. Clear? So matter may have mass and matter may have charge, right? That's only the common link between them, right? Otherwise there is no relation between these things. Okay? Now let's go over to the next thing. Polarity or type of charge. Okay, you could say polarity or type of charge. You see, there are, yes, right, of course, body means matter, isn't it? Matter always has mass. So polarity of charge. What is polarity of charge? You see, do you remember that magnets have two poles, north and south pole? Yes or no? Yes or no? Everyone remembers that? Of course, Trisha, that is right. Okay, so we have north and south pole for magnets, correct? You know, just like that, similar to it, by lots of experiments about attraction, repulsion. You know, magnets attract and magnets can repel each other, correct or not? Magnets attract and magnets can repel each other. Just like that, we know that charges can attract and repel each other. Put your hands down, everyone. Put your hands down. Okay, so I was saying that magnets have north and south pole, and you know that magnets can attract or repel each other, right? This is basic information that I'm sure you know. Just like that, in case of charges also, we have understood that there are only two possibilities. Either they attract or they repel. Okay, charges can either attract each other or they can repel each other. So this has made us to understand few sentences. Number one, like charges repel, just like in magnets. Is that clear? Like charges repel. Okay? Is it fine? Okay or not okay? Like poles repel in magnet. Okay, very basic stuff. Second sentence. Unlike charges attract each other. Okay, like charges repel each other and unlike charges attract each other. Okay. Now this is only possible if there are only two types of charges. I hope you realize. Okay. It's just like that we have only two varieties, like and unlike, only two possibilities. You get what I'm saying? There are just two possibilities. Either they are like that is same kind. Again, like charges means charges of same type. Okay? And unlike charges means charges of different type. Charges of different type. Okay? So, by experiments, it can be easily seen that because there are only two things possible, repelling and attracting, just like in magnets, here also there are only two possibilities. I will show you why. See, think of it. Suppose there are some three particles, let's say A, B and C. Okay, right now I am drawing A and B. We don't know the charge of anything, right? We don't know the charge of A, B and C. We don't know charge of any one of them. They are particles, remember, particles. Okay, I can draw them small if you want some clarity. So let's say, suppose A and B repel. So they push each other away. Did you understand what I have drawn? A and B repel. Okay? Suppose A and B repel. Now you are going to, suppose you take B and C. Suppose you take B and C and let's say you find that they attract each other. Right? Then every time when people have done this kind of experiment, where you take two things that repel each other and then you take one common, B is common here, okay, and then you take it with something else that attracts, you are always going to find that A and C, they are going to attract each other. Always, right? This has been tested so many times. Now this happens, right? These are all experimental observations. This happens simply because it's just like magnets poles. Okay, listen to this carefully. Suppose this was not, I am explaining it using magnets poles. Then this will also be not. Yes or no? You know, light poles repel each other. Clear or not clear? It's not exactly the same as magnets, but it is definitely similar. Okay? Then we know B is north, then this will be south. Correct or not? Okay, then A is north, then this will be south, so they will attract each other. Do you understand why it should always be like this? Do you understand why it should always be like this? Because there are only two. So experimentally this has been observed even with charges. That if you take three such charges A, B and C, and A and B repel and B and C attract, then you always find that A and C attract each other, always, right? So this means that there are only two things, same type or different type. That is A and B same type, so repel. B and C different type, so attract. Okay, and A and C will also be different type, so they will attract. Alright, and now because we have only two types of charges, let's put the definition of polarity. Number 3, sentence number 3, definition of polarity. It is the type of charge. Type of charge means we call it positive charge or negative charge, right? Is called polarity. Is called polarity. There are only two types or polarities of charge. I hope you understood this sentence, that there are only two, either positive or negative. There is no third, right? There is no third, right? Either positive or negative. There is no third. Don't say that zero. What about zero? Zero charge means no charge, right? Okay, zero charge means no charge, right? Okay. So, very simple basic questions to think of. If you put a proton P for proton, and you put another proton, two protons like this, okay, at some distance. Will they attract or repel? Will the protons attract or repel? I want answers, everyone. And like I said, interactions are necessary. You are in the class. Some of you are still having some confusion. Okay, both protons are same, isn't it? They are like charges. Clear or not clear? Both protons have same charge. They are like charges. So that means they will repel. Alright, that's why they will repel. Clear? That's why they will repel. Okay. But on the other hand, a proton and an electron. On the other hand, proton and electron, what do they do? Will they attract each other or repel each other? Attract each other. Very good. Because they are unlike charges. Do you realize you are looking at the foundation of our entire life? If a proton would not attract electron, there would be no atoms. And if there are no atoms, you would not be having this physics class right now, isn't it? Acha, Partharaj, M. Chalo, a question for you. This is a question for you, Partharaj. If two electrons come close to each other at a distance of 0.5 femtometer, what will happen? Will they attract each other or repel each other? Partner, answer. Parthraj, answer. તો પછી જે વસ્તુની બરાબર ઇન્ફોર્મેશન ન હોય ને પ્લીઝ બીજા ચેપ્ટરનું છે ને ચાલુ ચેપ્ટરે બોલવું નહીં. I am requesting everyone. Okay, if you would ask it as a question, I'd be most happy to answer that. All right? Okay, here is extra information for you, Partha. Nuclear force is more weird than what you can even imagine. Let me tell you. You said that when we bring two particles close to each other of some femtometer distance, they will attract. Not at all. For less than 1 femtometer, the nuclear force is amazingly repulsive. Alright? Okay? It is amazingly repulsive for less than 1 femtometer. So I am requesting you specifically, because this is not the first time this has happened with you. Please do not comment with incomplete information. Alright? Please do not comment with incomplete information. Got it? Okay. So basically Parthraj was talking about nuclear forces that we are going to learn about in the chapter of nucleus. Okay? Others don't need to worry about it. Alright. So, what I said is absolutely true. When you have unlike charges, they are going to attract each other, and when you have like charges, they are going to repel each other. That's confirmed. Alright, there is no doubt or no problem with it, because remember, even here we are talking about forces that are related with charge. Let me tell you something interesting. These are two protons. These are two protons. Let's say this case. Right? Do you realize that on this proton actually there will be one attractive force also between these two? There will be one attractive force also. Can you tell me which one? Maybe you don't need to worry about that. Okay? You don't need to worry about that right now. What happens at half femtometer should be nobody's business at this moment. Okay? Because you are in no position to understand anything about it. So I am asking you, there is one attractive force between these two. Which force? I am talking about proton and proton. I am talking about proton and proton. There is some attractive force between the two protons. Which force is that? Gravitational force. Very good. So what will happen is, if you think of FPD of this proton, there will be one gravitational force right side. Why? Because this also has mass, this has a mass. Correct or not? Both protons have a mass. Okay? And there will be an opposite or repulsive force. Okay? This is due to the charges. Okay? Basically it's called electric force, but it's okay if you don't worry about the name. It's called electric force or electromagnetic force, and this is gravitational force, right? So there will still be two forces acting on it, but yes, you have learned this very early in 11th standard that gravitational force is very, very small compared to the electromagnetic force, isn't it? So normally in this chapter, we will ignore gravitational force. Why will we ignore gravitational force? Because of this. Okay? Because of this. Yes, one more thing. I see that everyone is taking part, interacting with me today. I'm really liking it. And I hope you will maintain the same thing even when we go on to solve numericals. Right? Okay, બાકી થિયરીના 5 સેન્ટેન્સ લખવાથી કઈ ફિઝિક્સ થતું નથી. I am sure you remember that. Okay? ગમે એટલી થિયરી જીકમ જીક કરો, બોલો, સાંભળો, યાદ રાખો, ગોખો. થિયરીથી ફિઝિક્સ થાય નહીં. Unless you can use all those concepts in questions, it's useless. Right? Because physics is all about solving real life problems. Okay. Fine. So this is the definition of polarity that you can memorize for board exam. Okay. Now let's talk about charge of elementary particles. Number 1. So charge of some fundamental or elementary particles. Okay, number 1, charge of proton. Do you know how much is charge of proton? Everyone? Can you write it in the chat box? Come on. How much is the charge of proton? Some of you are making some very silly mistakes. Okay, charge of proton is Qp. Q is the symbol of charge, everyone. Normally the symbol of charge is Q. Okay, either capital or small, but anyways Q for charge, P for proton. Charge of proton is 1.6 into 10 raised to minus 19 coulomb. Alright, which we can often write as plus 1e or just 1e. Okay, or e, simply e. Alright. Okay, E stands for this value, everyone. E stands for this value. Understood? So charge of proton is 1 E, and 1 E means 1.6 into 10 raised to minus 19 coulomb. Okay, charge of electron. Charge of electron. Everyone, how much is charge of electron? QE now. Charge of electron. How much is charge of electron? Same? Are you sure? Charge of electron is minus 1.6 into 10 raised to minus 19 coulombs. Charge of electron is minus 1.6 into 10 raised to minus 19 coulomb. That is minus 1 E or simply minus E. So now I am going to ask you a very simple question. Which charge is more? Is charge on proton more or charge on electron more? Which charge is more? Okay, so this can be confusing, but let's make it very simple. What is really different here? What is different here between these two? Number one, number two is polarity. What is different here is polarity or type. So you know, like I said, we have called the type of charge as either positive or negative. We have called the type of charge as either positive or negative. Alright? Okay, they are types. So this plus and minus is actually indicating type of charge. It is actually indicating type of charge. Right? See, you might find it strange, but listen to this carefully. We could have easily called the type of charge as red charge and blue charge, to be very frank. Right? We might have said that charge of proton is 1.6 into 10 raised to minus 19 red. Okay, instead of saying positive, it's positive E. Instead of that, we could have said red E. And just like that, for electron, we could have called it blue E. Alright, it would still be okay. Nature doesn't mind that. But why then do we use positive and negative? Right? Why then do we use positive and negative? We'll see that when we come to properties of charge. Alright? So, positive and negative are just given by humans. Remember, nature doesn't even really bother what you call positive and what you call negative. Suppose you flip them. Let's say today we decide, okay, all the humans of the world decide and say that from now on proton's charge will be said to be minus 1.6 and electron's charge will be said to be plus 1.8. Nothing will change. All the physics will remain same. Right? All the physics will remain same. Right? Everything in nature same. So plus and minus is just what we have called it. Okay, just like you could call it red and blue. Now, so the charge on both of these is same. It's just that there are different types of charge. Again, like I said, it's like comparing 3 oranges and 3 apples. Which fruit is more in number? Both are same, but they are of different type. Did you understand? 3 oranges, 3 apples. Clear? They are same in value, but just different type. One is positive polarity, the other is negative polarity. Right? Absolutely clear? Okay, now third one that is of importance for us, charge of neutron. Okay, what is the charge of the neutron? What is the charge of neutron? Zero, of course. Okay, 0. Now, yes, there was a question, let me just repeat it. Mahavir, I have been explaining it many times. Please pay attention. I said that these are same in value or magnitude, but their polarities are different. So, can you actually write this Can you say that 3 apples and 3 oranges are equal? Can you say that? Ask yourself this. Can you say 3 apples and 3 oranges are equal? Is it so confusing question? Is QP equal to QE? No, of course not. This is wrong. QP is not equal to QE. Clear? Okay. Fine. So that's about charge of some basic particles like proton, neutron and electron and all that. Okay. So based on this, we may have to find out charges of other things in future. Okay. Now, the next thing that we are going over to is properties of charge. Next thing we are going over to is properties of charge. So like I said, charges have different properties. Okay, charges have different properties. So first one of them is that charge is scalar. Charge is a scalar quantity, right? It doesn't have a direction, only has a magnitude. Okay, just a value. Again, this plus and minus does not indicate direction. Let me be very clear about it. Plus and minus does not indicate direction. Just like mass is a scalar, charge is also a scalar. Okay, I see the video is stuck. Can you hear me, everyone? Can you hear me? Okay, fine. Then actually, by the time we record and do all this, right? Okay, fine. We are going to end this class today. We will continue tomorrow. All right? We will continue tomorrow. Yeah, I will repeat everything. Properties of charge. We'll do it. We'll start from that. Okay. Goodbye, everyone.